Welcome. Today we're going to learn how a quadratic function is graphed as a parabola and that we can change the parabola or do transformations to it. Move it over, left and right, up and down. We can make it skinnier. We can make it wider. Ooh, I didn't mean to do that. Ooh, let's go right there. All right. So let's first graph what we call the very basic or the parent quadratic. So we're going to use function notation, f of x. So I'm right over here, f of x equals, and the very basic parent function of the quadratic is x squared. So y, remember f of x, that's just y equals x squared, is this parabola here. And again, I can zoom out. You can see that it just keeps going up and 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 up. And then I can zoom back in. And we're going to stay zoomed in to about right there. Maybe a little right there. All right. So this is what we call the parent function, or the most basic quadratic function. It's this opened upward. And hopefully when you did those quadratic tables, you realize that that's what happens. Again, you can always plug values in for x to see what happens as you plug in negatives, because a negative number squared is always going to be positive. Negative 2 squared is 4. 2 squared is 4. 3 squared would be 9. Negative 3 squared would be 9. 0 squared is 0. So it's this kind of this U-shaped figure. Now, what I want to talk about is we are going to do some transformations. We're going to shift this quadratic into different positions. Now, to do that, I first want to go to this right here. And if I would give you a suggestion or a good recommendation is to write this down so it can help you. All quadratics can be written in the form of this y equals some a, which we'll talk about as a stretch, times in parentheses an x minus h, where h is a shift left or right or a horizontal shift, in parentheses squared, plus some k value, which is a vertical shift up or down, shifts it up or down. So I like to start with the k first. It's the easiest to understand. Let's start with the k and say, all right, k down here at the bottom, k affects the parabola by shifting it up or down. It's very simple. If k is positive, then it shifts it up. If k is negative, it shifts it down. Now remember, this is a plus k, it's after the squared. So let's go back to the graph, this graphing thing, and let's find that out. I'm going to do a new function. I'm going to do g of x, and I'm going to equal, and again, I'm still going to do my x squared, but this time I'm going to add or subtract after the fact. So let's add 2. And if you'll notice, that put it above. It shifted it 2 units up. It's still the same parabola, it's just shifted up. Well, I want to be careful. It's not the same exact parabola, but it's the same size, shape. It's just been shifted up. I could do plus 6. Shifts it way up here. So that vertex now is at 6. Now if I put minus 7, it's going to shift it way down here to minus 7, right? If I put, and it doesn't even have to be a whole number. I can do minus 3.14415, in other words, pi. And again, if I zoom in a little bit, hopefully you'll notice that I'm not at 3, I'm a little bit below. So it doesn't even have to be a whole number. But it shifted it down because I'm subtracting. I do plus 1, it'll shift it 1 unit up. So just remember, after the fact, after the squared, I mean, this would be a vertical shift up if it's plus a positive number, and it's a vertical shift down if it's minus a positive number. Now let's talk about the h. I like to talk about the h next. Now be very careful here. The formula is written as x minus h squared. So when I come down here and say, if h is greater than 0, then it shifts it to the right. That's true as long as there's a minus sign there. So it will seem backwards when we go look at it. If h is less than 0, then it shifts it left. But again, less than 0 means this is a negative number and I'm minusing a negative. Down here, again, I put this, be very careful, because if it reads x minus 7 squared, then h is actually positive. If it reads x plus 5 squared, then h is actually negative. It's minus a minus. Now, if you need to take a minute to think about that, I want you to do so. But let's go show you what I mean. So now I'm going to come back to here, and I'm going to change my g function. I'm going to actually add the 2 before I square it. And now when I hit enter, let's see what happens. It actually shifted it. Whoops, I don't mean to do that. My mouse is really sensitive. It shifted it 2 units to the left. But it's a plus 2, right? Shifted it to the left. Think of that as a minus a minus. Now let's think logically why that's so. The original parent function, what's the very smallest x squared could ever be? The very smallest it could be is 0. Because if I plug any number in other than 0, when I square it, it gets larger. 1 squared's 1, 2 squared's 4, 8 squared's 64. If I plug a negative 1 squared, that's positive 1. Negative 2 squared's positive 4. Negative 8 squared is positive 64. That's why 0 is the lowest possible outcome for this f of x function. Well, the same principle applies here. What's the very smallest this parentheses that's being squared could be? Well, the very smallest it can be is when the parentheses itself is 0. Well, when is it 0? When x is negative 2. Negative 2 plus 2 is 0. 0 squared is 0. So it's at its lowest point when the parentheses is 0. So now if I come back here and let's say I put minus 5, now think in your head for a minute, minus 5, what value of x will make this parentheses 0? A positive 5. So I'm minusing a positive 5. When I hit enter, which I haven't done yet, it shifts it all the way over here to 5. So remember that. It's kind of the opposite of what it seems to be on the inside for your horizontal shift. By the way, that's why we use an H back here, H for horizontal shift. I don't know why they don't use a V for vertical shift or something, but they use K for their vertical up and down, H for horizontal left and right. Again, let's do a couple more just to make sure you realize that it doesn't even matter if it's a decimal. If I do 3.5, since I'm adding, it's going to actually shift it to the left. Shifts it to the left, 3.5. If I'm subtracting, minus 7, it's going to shift it to the right, all the way over here to 7. Okay, that's a horizontal shift. The last thing I want to talk about, I'm going to go right back to the original, lays right on top of each other, is the a value. The a affects the parabola in the following ways. If a is negative, it flips it over, flips it vertically, so it's upside down. If the absolute value of a is greater than 1, it stretches it vertically. In other words, it makes it taller or skinnier. Now, the reason I use absolute value is because if I use 2 or negative 2, it's still going to make it taller or skinnier. Positive 2 would keep it opened upwards, but if I put a negative 2 in for a, it would open downwards. It flips it plus makes it skinnier. But if I'm using a number that's really close to 0, 1/2, 1/4, negative 1/2, negative 1/4, negative 1/5, then it would open downward but be wider. So let's look at that and see how that works. So I'm going to come back here and I'm going to plug in a 2. Now again, if it's larger than 1, it should make it skinnier. And lo and behold, it does. It's narrower or skinnier, or what we could say is taller. Again, if I plug in a 7, it should even be narrower or skinnier. Forgot to do a negative. Let's do a negative. And let's just do a simple negative. It flipped it upside down. And if you think about it, that makes sense because x squared will always be positive, and now I'm making it negative after the fact. Now let's do a negative number that's larger than 1, or negative 1. So let's do a negative 5. Again, it's going to flip it, but it's also narrower. Lastly, let's do the number that's smaller than 1, like 1/2. That should make it wider. Now I made it positive, so it should flip it back over. And look, it's actually a little wider. If I make that fraction even smaller, 1/9, it's even wider. If I make it negative 1/9, what would negative 1/9 do? Well, it's going to flip it over and still be wide. Now, in your lesson today, we're going to combine all those. So again, we're going to take our original x squared function. I'm going to put in here x plus 2, and let's close the parentheses. I might put a 2 out in front, and then I might do a plus 2. And the question is how is that going to transform it? Well, I start in parentheses, follow order of operations. If I add 2, that actually shifts it not to the right, but to the left. If I times by 2, it's going to make it skinnier. And if I add 2, it's going to shift it up 2. So I should start right here, and it should be skinnier, opened upward. Here we go. Let's see. And lo and behold, it is. If I was to do a -1/2 outside, then I do a, let's say, a -5, and then let's say do a -3. Again, what's that going to do? Well, the -5 on the inside of the parentheses will shift it 5 to the right, so it's shifted over here. The -1/2, negative is going to flip it upside down. The 1/2 is going to make it come out a little wider, and then the -3 shifts it down. So I go in over 5, down to 3, and it should be a little bit wider and upside down. Let's see. And lo and behold, it is. That is a little bit wider than this one here. Again, if you have any questions, definitely just watch it again or ask me when you come to class.